Hey everyone, my name is Kanaya Gupta and welcome to my YouTube channel. And today we are going to discuss house robber dynamic programming problem. Guys, this problem is very common problem. Even a lot of companies like Google, Microsoft, Amazon, Facebook have asked this question in the interview. So our intention is to not only just teach you how to solve this problem, along with that we are going to focus on the problem which is based on the similar pattern. So if you watch this video till the end, you will be able to solve more than one problem based on the similar pattern. Before moving ahead, make sure you have subscribed to my YouTube channel and hit the bell icon so that you don't miss any update. Let's start. So this is the problem statement, guys, which I have taken from the LeetCode platform because they have a good story around it. But this is not the actual problem. We'll see what the actual problem is and how small it is, but later on in this video. But for now, focus on the problem statement. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So given a list of non-negative integer representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. So to understand a little more, we will see the sample input and output, guys. So this is the input which we have got. So you can see here this is a single dimensional array. So in that we have and each array block represent basically the houses. You can treat like this. So all houses are adjacent, and whatever the number mentioned between, this is nothing, just a money. 2793 is a money. So you have to collect the maximum amount of money from these adjacent houses without alerting the police. It means you should not steal or rob the houses which is adjacent to each other. So the maximum collection which you can get from this array is 12. But how? So you have to choose 2, 9 and 1. So here, if you rob the houses which is highlighted in a green color, you will get the total amount is 12, because 2 from the first and 9 from the third and the 1 from the fifth one. So if you total it, you will get the 12. By seeing this problem, it may be look that we are doing a robbery in an alternative manner. This is not true, guys. Because just you wanted to leave one house in between, it doesn't mean you have to rob in an alternative way. Here the main thing is like you have to leave at least one house once you rob any house. Okay, so you have to leave the adjacent house. So here if you are choosing any house, you cannot rob the immediate next house at least. So here the problem statement is not saying you have to do the robbing in an alternative way. They wanted to calculate the maximum amount which you can collect from the house, but that house should not be adjacent. So there may be a one house difference in between, or there may be more than that. So it doesn't matter how much houses you are leaving in between, but the output of this should be maximum. And let's see the another input which will clear your doubt. So this is the second input, guys, where we have a houses with money 5, 3, 4, 11 and 2. So in that case, the output will be 16. Why? Because we are going to choose 5 and 11 in that case. You can see, guys, here we have taken 5 and 11. So it's not like we are going to rob in an alternative way. We have to just make sure whenever we are doing a robbery, that two houses should not be adjacent to each other. So there may be a difference of one house or two houses or more than that, but we are more focused about the maximum amount which we can get. So here the maximum amount the robber can get is 16. So now I hope the problem statement is clear to you. So let's talk about the algorithm now. If you think in a broader way, guys, there are a lot of houses adjacent to each other, and the robber has to take the binary decision whether he has to rob the house or not. So in the same way, we have divided our algorithm, or basically the cases which we are going to study, in two parts. When he chooses to rob the house or when he doesn't. So this is the first case, guys, where robber robbed the current house. So when he is chosen to rob the current house, if current ith house is selected for robbery, it means he cannot rob previous I minus 1th or I plus 1th house, but can safely proceed to the one before previous I minus 2 or I plus 2 and get all communicative money that follows. Guys, just to highlight here I have mentioned I minus 1th or I plus 1th. It totally depends from which direction he is going to rob. If it's taken from left to right or from right to left. So based on that, it may be I minus 1 or I plus 1. In the similar way, it may be I minus 2 or I plus 2. Okay. So now these are the houses, and assume currently 11 is the ith position where the robber is there. So here the robber has to make a decision because we are taking the case where rob the current house. So robber has decided to rob the current house, right? If you have decided to rob the current house, so given the problem statement, we can say the maximum amount of money he can get is a robbery of the current house plus the money from houses before the previous. So if you see, before the previous will be 5 and 3, whatever the money he have accumulated so far before the previous. So previous is 4 basically, because he cannot rob the house which is just nearby. So he has to take this decision. If he is choosing to rob the current house, it means the ith house, he will get the maximum amount of money which is accumulated from the houses before the previous. So this is a one condition, one case which can be happen. And the same thing we can write in terms of equation something like this. Ith house is selected equals to current house value, which is 11, basically the array value, plus rob I minus 2. Why I minus 2? Because we have to leave the previous one. We cannot rob if we are choosing the ith position. We cannot rob the ith minus 1. So the total amount previously collected up to I minus 2, rob I minus 2, plus the current house value. So this is the amount which we can get. Guys, rob is a function. Okay, we'll tell you later on what is exactly, but just bear with me for some time. And the case second, as we have talked about, when robber decided not to rob the current house. So this is the another way. So this is the another option which the robber has. So there are only two options, guys. Either he will choose to rob or either not. So this is the second option. Do not rob the house. So in that case, if current ith house is not robbed, it means robber will get all the possible money of I minus 1th or I plus 1th house and so on. So the total money he has accumulated before that. So suppose in this array, robber decided not to choose the current ith house. So he is eligible to get the maximum money which he have got from the previous houses. So the money from the previous house robbery and the money captured before that. So it's eligible to get all the money from the previous houses, and which can be represented in terms of equation something like this. If ith house is not selected equals to rob I minus 1. It means rob is a kind of function and you can get all the money from the houses which is till the I minus 1. What is the maximum amount which we have robbed so far till the I minus 1? You can take that away. And if you combine both the cases, you can come up with such kind of key relationship which will look something like this. Here rob of I equals to math.max, ith house is selected, comma ith house is not selected. Because here robber intent is to get the maximum profit out of it. So he has to choose one out of the two options. Either he will choose the case 1, either he will choose the case 2 based on the maximum amount. So that is the reason we have used math.max, because we want every particular point or the house, we want the maximum amount, right? So there will be only two cases, just as I said. Either I will choose the house or I will not. So that is the reason we have to decide based on that. Either I will choose ith house or either I will not. So this is a formula kind of key relation which we have got from the above two statement. So now you understand the logic and algorithm behind it. So now it's time to solve this question. As we know, To solve this question, we always used our dynamic technique, which I have already informed you earlier. So we are going to use the fast method, guys. If you are not aware about the fast method, I will request you to watch my previous videos in this lecture series so you will know what the fast method is. And the link is mentioned in the description. So here F stands for find the recursive solution. So now we know the problem. So we are just try to come up with a recursive solution for that problem. So here is the recurrent solution from the problem. If you are having any difficulty to make this, just compare it with the statement just we had. So if ith house is selected equals to current house value plus rob I minus 2. So if you try to compare both the equation, you will see here A in a recurrent solution, A stands for array and I stands for the array index, and T is a function. Instead of rob for finding the recurrent solution, I have used T. So now in the current house value is nothing, just a value of the array. So that's why I have used AI. So if house is selected, this is the relation, and if house is not, ith house is not selected, we are going to use rob I minus 1 or whatever the function you have. So in the current relation, we have function in terms of T. So I can write TA I minus 1 if ith house is not selected. I hope guys you are able to relate the reconciliation with the statement which we have received from our analysis. Now we have to come up with a recursive solution based on the reconciliation. So here is the recursive solution. So we have translated this code into a recursive solution. As when we write our solution, we are not going to use T and all. So I have just used the rob again. So you can see rob is a function. Here argument is A and I. A stands for array and I is the index. So it's the same thing guys. If I is less than 0, return 0. And after that, if ith house is selected, then we are going to calculate this, which can be written something like this. It's the same thing guys, right? And if ith house is not selected, we are going to calculate this. And at the end, because we wanted to calculate the maximum profit for the robber, so we have to return the maximum among these two when he is chosen to rob the house and when he is not. So this is the recursive solution for this problem. And as we know, the recursive solution has a exponential time complexity. So this problem has a time complexity of 2 raised to the power n. So which we will reduce up to a polynomial time. We'll see how. So this is the first step guys, fast method's first step, which is to find the recursive solution. Now we are going to move to the second step, which is A, analyze the solution. If you think about, the houses are adjacent to each other and you are at place suppose 11. So if you have chosen to rob the third index, so you can get all the money which you have collected so far till the first index, right? So in the similar way, if you have chosen fourth index to rob the house, so you can get the money till the second index, whatever you've chosen. So if you compare both the things, you can see the initially 0 and 1, the range is getting overlapping here, because if you are moving ahead, you also need the data which is already calculated before. So once you know this problem is an overlapping problem, so you have to store the solution in some storage, which is also called as a caching mechanism. So you can cache this solution and retrieve it from there. So let's move on to the next part, which is S, save the solution. And this technique is also called as memoization. So in that we have a two variation guys. The first variation is when cache declaration is on global level. So if you see this code, here we have defined this cache on a global level. And this is the same solution guys, which we have just solved. We have just added one caching layer in between. If anything we have already calculated, we are just going to return back from the cache. Else we will calculate the maximum amount and store it in a cache and return. So this is a one variation guys, where we have declared the cache on a global level. And the second option is when we can pass the cache as a method argument. So this is also the same solution, just we are passing the cache in a method argument instead of declaring as a global label. and the complexity of this solution is O(n). And the space complexity of the solution is also O(n), because here we are using the array. You can see, guys, we have reduced the exponential time to the polynomial time. So this is the power of dynamic program. Let's move on to the next step, which is T. So here we have tweaked the solution, because so far whatever we have done, that is a DP with top-down approach. But the pure DP solution includes the bottom approach, because we want to remove the recursion overhead from the solution. So this is the solution, guys. So in that, if you see, we have removed the recursion part. There is no recursion at all. And if you see here, first we have taken a base case. Suppose we have only one element in the array. So what is the maximum amount which a robber can rob? This is A0, right? So we have defined this as a A0. And suppose we have an array of size 2, then what is the maximum amount the robber can rob? So that we will calculate based on the mesh.max. Why? Because if you have only 2 elements or 2 entries in the array, so you can choose either of the one, right? Because you cannot choose the adjacent one. So you have to take the maximum to gain the maximum amount. So that is the reason we have chosen mesh.max here. And if you have size more than 2, then we are going to calculate based on the formula which we have discussed earlier. This is the same thing, guys. And if you see these 3 steps, we can combine into something similar to this. So I have accumulated all those 3 steps in one single formula. So there's no change in formula, guys. It's totally same whatever we have started from that till here. It's totally same. And the complexity of the solution is same, which is O(n). But the main thing about this solution is it's a bottom approach. So there's no recursion overhead. So that is the reason this solution is much better than the previous one. So now here comes the efficient solution, guys. So this is the efficient solution. Why? We'll discuss it. Suppose this is the array, guys, and we are at point second index. You can say is ith index basically. And the previous one is just like before the ith index, and the previous 2 is just like before the previous one. So initially we have taken previous 2, which is A0, and previous one, which is a max of A0 and A1. And in the loop, what we are doing, we have assigned previous one in a temporary variable and calculating the previous one based on the formula which we have discussed. Because we know if you are at ith position and you wanted to rob that house, then the formula will be this: previous 2 plus AI, comma previous one. And when you move on to the next step, the previous one will become previous 2. So that is the reason we are storing previous one as a temp, so that the temp can be assigned into the previous 2. So the next step, previous 2 will take the place of the previous one. Guys, if you can relate, this is kind of Fibonacci also, we have done such kind of stuff, right? So you have to think out of the box. Once you have the solution, just try to think whether we are going to use the previous calculation or not. If you see here, we are not going to use the previous calculation. For just to help you, let me go back and tell you one thing. So in that, if you see the cache value we are calculating, it totally depends on the cache I-2 and I-1. So if you want to calculate any index or ith index, you need 2 things: immediate I-1 and I-2, the previous of the previous. So only 2 indexes, previous 2 indexes you need. You don't need all the indexes. So that is the reason we have got this idea that we will not store any element apart from the previous 2. So that is the reason here I have used 2 variables. Instead of using the complete array, we are using only 2 variables, which is required, and we have modified a solution a little bit. So this is the efficient solution, guys. Why? Because in this solution we are not using any extra space. So now the space complexity for the solution is O(n), and the time complexity is same, which is O(n). So let's do the pattern analysis, guys. Now we have solved this problem by using multiple ways. Now here comes the pattern analysis. So this was the problem statement, guys, which we have got in a question, which is a complete story, right? But now I'll tell you what is the exact problem statement behind it. The exact problem statement will look something like this. Given an array of positive numbers, find the maximum sum of a subsequence with the constraint that no two numbers in the sequence should be adjacent in the array. If somebody will ask you a question, something like, given an array of positive numbers, find the maximum sum of a subsequence with the constraint that no two numbers in the sequence should be adjacent in the array. So can you do that? Yes, because it's the same. It's a house robber problem. But just they have wrapped this story around this problem. Otherwise, the problem statement is very clear and simple. It's only a one-liner statement, guys. And they have wrapped that statement into a story, which you can see. It's a 5-6 lines, right? So you should know how the pattern is derived. You should not think that whatever you have just learned can be applied only the particular problem. The same thing can be applied on a different problem, but just you need to filter it out. What is the exact base problem statement, right? But let me tell you one thing, guys. This is not enough. Again, you can filter this statement to another one, and I'll show you just now. So the exact problem is this. Find the maximum sum in an array such that no two elements are adjacent. So if somebody will ask you, can you write a program to find the maximum sum in an array such that no two elements are adjacent? People will be surprised. They will be thinking how we should do that. If you have already done house robber problem, then you should not face this issue because it's the same problem. Just there's no story around it. You should not think it's a different problem. So don't focus on the story. Focus on the main part. Try to extract the main information from the problem statement, what they are asking for. And once you are able to achieve this, I'm damn sure you can solve any kind of problem if it's based on matching to a similar pattern. Now you know the solution of find the maximum sum in an array such that no two elements are adjacent. So if you know this base problem and you know the solution of this base problem is this, which we have just learned in this lecture. So you can solve any problem which is having this filtered problem statement. Because people, whenever they will give you a problem statement, they will wrap up the story around it. So you have to focus on the main problem, what exactly it's asking for, which requires some practice. So this was the analysis, guys. So I will say, do not remember this solution based on house robber. Map to this with a generic problem. If somebody will ask you find the maximum sum in an array such that no two elements are adjacent, you are going to use this kind of technique or solution to solve this problem. I hope, guys, it's clear to you how we have reached so far and how we can filter it out the exact problem. Now the time is for the demo part, guys. Here I have coded all the solution, guys. But one extra thing which I have done it here is just to edit the extra condition, which is called a corner case basically. In the slides, guys, I have not shown you this because it's a redundant information for all those methods. So I have not shown you. I have showed you the main concept or the logic which was required. But whenever you are doing the programming, you should also handle these corner cases. If you are going to write this solution in a LeetCode or somewhere, it will not work. So that is the reason you have to include this corner cases. What it says, if array is null, if the input is null, you are going to return 0. If only one element are there in the input, you are going to return the same element as a maximum amount which that robber can receive. These two lines are added in every method, guys. Apart from that, each and everything is same which I have showed you. So this is the same thing, guys, and we have all different methods and approaches that I'll put it on GitHub so you can download it. But before that, we'll just run this at least once to see what is the time that every approach is taking. Okay, so in the output, first I need to mention the number of elements present in the array. So this is suppose 5, and the number of elements space separated. So suppose 2, 7, 9, 3, 1. This is the same input, guys, which I have taken in the slides. So that is why I am using the same, because I know what would be our answer. So the answer is 12, guys, but we need to see the time. The first approach is taking this much time, which is totally recursion, and this is again the recursion with memoization, and this is also a recursion with memoization, but the cache difference is there. And this is the solution, which is a bottom up, and this is the optimized final solution. So here also guys, you can see this time is showing more, but this is the efficient solution because we are not using any extra space over here. I hope guys you have enjoyed this video. If you find it useful, please let me know in the comment section and share among with your friends. Thanks for watching guys.